And just my disclaimer that this is going to be recorded and posted on our D2L website. All right. Part A here. This is where we're making our chart. Although we're online, I see my tablet's giving me the same crap it always does. What in hell? Hold on, I'm sorry. All right, so starting with part A. Descartes' rule of signs, we're making our charts. Positive real zeros, negative real zeros, and complex. We want to start by counting the number of sign variations in g of x, because that'll tell us the maximum number of positive real zeros. So looking at the number of sign changes, we have 1, 2, 3, 4. So we have 4 sign changes. So that's our first option, but remember Descartes tells us that it is either that or less than that by a multiple of 2. So if I subtract 2 from 4, I get 2. Is that a reasonable answer for a quantity?
Yes.
Sure is. Anything other than a negative is fine. I'm going to subtract 2 a second time. I get 0. Does that make sense for a quantity?
Yes.
Sure does. We subtract 2 one more time, we get a negative 2. Negatives don't make sense when we're talking about quantities. So we have 3 options, 4, 2, and 0 for the number of positive real zeros. Now we're moving on to determine the number of negative real zeros. So we need to look at the number of sign variations in g of negative x. Recall that I mentioned there is a shortcut to finding g of negative x. All you need to do is change the sign of the odd degreed terms. So g of negative x is going to be 3x to the 4th plus 20x to the 3rd plus 51x squared plus 56x plus 20. So how many sign changes do we have in g of negative x?
0.
We have how many?
0. Nothing there.
0.
Yeah.
And if we subtract 2 from that, we get negative 2, which is certainly not a quantity number. So we end up with 3 options for positive real zeros, but only 1 option for our negative real zeros. To fill in the first 2 columns of our chart, we're going to do every possible combination of those options up top. So we'll do 4 with 0, 2 with 0, and then 0 with 0. Next, we fill in our complex column, remembering that each one of our rows has to add across to be what?
The leading power or greatest power of 4.
The degree of our polynomial. So this time our degree is 4, so I need to make sure each row adds across to be 4. So we're going to fill in whatever number would accomplish that. So first row would be a 0, second row would be a 2, last row would be a 4. And there's our table. So what guidance is this table going to give us? When I get my list of possible rational zeros, should I start with checking positives or negatives?
Positive.
Positives, because in no situation are we going to have a negative. So checking any of the negatives would be a total waste of time. So we're only going to check positive numbers. In part B here, we're ready to list out our possible rational zeros. We're going to take the factors of our constant and divide it by the factors of our leading coefficient. And remember, everything gets a plus or minus with it. So we're starting with the factors of our constant, 20. What are their factors of 20?
1 and 20. 2 and 10.
5 and 4.
All right, great. And then we want to divide it by the factors of our leading coefficient, which is 3. 3 has factors of 1 and 3. And now we want to simplify this list. So everybody's a plus or minus. And then I'm going to take each of my numerator numbers over 1 and then each of my numerator numbers over 3. So taking it over 1, and I am going to flip these just in increasing order. And then each one of them over 3, 1/3, 20/3, 2/3, 10/3, 4/3, and 5/3. There we go. Questions on our chart or our list of possible rational zeros? Part C, this is the long part. This is where we now want to test all of these possible rational zeros. Well, not test them all, just enough until we can rewrite this as the product of 4 linear factors. I always like to check +1 first, and I actually use remainder theorem to check +1. And the shortcut I mentioned last week for checking 1 is to simply add up the coefficients of your polynomial. So if we do that, what do I get here? It's -76 and then +74. So that's not going to give me 0. So I know right away +1 is not a 0. Now we're going to move on and check any other number other than +1. But recall that our chart tells us not to bother checking any negative numbers. So which positive number would you like to check next now that we know that 1 doesn't work?
2.
Sure, let's check 2. I usually stick with this kind of small numbers to begin with as well. Recall that when doing synthetic division, you must include a placeholder if you're missing one of your terms. I've seen students come to my office hours with like 6 pages of work and feeling super frustrated that they did all this division and none of them worked and they had missed a placeholder. So be sure you recall to put those in. What's that? 23. All right, the remainder is 0. Good choice. Since we found a 0, that means that we found a factor and we can start factoring our g of x. All right, so 2 is the 0. What's the factor?
X minus 2.
X minus 2. And then the degree of our next factor.
3.
is going to be degree 3. 3x to the third minus 14x squared plus 23x minus 10. Right. Once we get down to a cubic and we have 4 terms, I always try to factor by grouping, because the factoring techniques I already know is way easier than all this division stuff. But when I try to factor by grouping, I don't end up with a common binomial factor, so it's not going to work. But the time it does, I'm going to be super happy, so I try it every time. Okay. Well, let's try another number. What do you want to try next?
5.
5. Remember, we're using the coefficients of our cubic factor here because we're trying to continue to break it down. We get a remainder of 130, so that does not work for us, but we can get some information out of this attempt. Notice that we divided by a positive number and our entire bottom row is full of positive numbers. That means that 5 is an upper bound. Since we have a positive number that we were dividing and then all positive numbers at the bottom. So we need to choose a number smaller than 5 next.
4 maybe? Wait, no, that might just be similar to 2 because it's a multiple.
Say that again, Anthony?
Would 4 have the same effect as 2 since it's a multiple of 2?
Not necessarily. So we can certainly try 4. Remainder of 50. So that one doesn't work either. But it does not tell us that 4 is an upper bound. Okay, so what do we want to try next? And my notes are in my office and downstairs, so I can't even guide us.
10/3.
Let's try a fraction. Let's try 10/3. And if this doesn't work, I'll run downstairs and get my binder with all my notes in it.
I already did this equation and I got -2/3 as the other one.
-2/3, but we're supposed to have no negatives.
Oh, never mind. +2/3. Sorry.
Positive 2, okay.
I
All
was
right,
looking
let's
at
jump to
that.
+2/3 then. But this is kind of it with these problems, that sometimes you choose lucky and the problem's short, and sometimes you check like a whole bunch of numbers. So you just have to be patient and check the numbers. You can always use remainder theorem in your calculator where you just plug the 0 into the polynomial, and if you get a remainder of 0, then you know it works. So you can always do that as well. Just because I don't use remainder theorem all the time doesn't mean that you shouldn't use it if you feel it's more effective for you. 2/3 times 2 is 2, so that's a negative 12. Negative 8, which is 15, and then 10, there we go, 0. All right, so g of x says that we have x minus 2. We just got a 0 of 2/3, so that's going to give us a factor of x minus 2/3. Our next factor is going to be quadratic. 3x squared minus 12x plus 15. And once we get down to a quadratic, we do not have to test zeros anymore. We'll be able to factor this by using traditional methods. And if it doesn't factor, we'll use quadratic formula and then work backwards from quadratic formula to the zeros. But first thing I notice is that quadratic factor has a common factor of 3 that we can factor out. Putting that 3 out in front. Leaves us with x squared minus 4x plus 5. We try to come up with two numbers that multiply together to be positive 5, but add together to be negative 4. There are no such numbers, so we're going to have to use quadratic formula to get the zeros and then work backwards to the factors. X equals a negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 5 all over 2 times 1. So x is going to be 4 plus or minus the square root of 16 minus 20 all over 2. That's 4 plus or minus the square root of negative 4 all over 2. Square root of negative 4 is 2i, so x is equal to 4 plus or minus 2i all over 2, which simplifies down to 2 plus or minus I. Now that we have the zeros, we can get the two factors. And I recommend splitting it up and not having that plus or minus notation. So we're going to have x equals 2 plus I and x equals 2 minus I. But to get the factors, we got to set them equal to 0. So we get x minus 2 minus I equals 0. X minus 2 plus I equals 0. And then these are our other two factors. The biggest mistake I see with a problem like this is that people get down to the 2 plus or minus I, and then they tell me that those are the two factors. Remember that each factor, unless it's a numerical GCF that you have out in front, every single one of your factors should have an x in with it. We end up with g of x equals 3 times x minus 2 times x minus 2/3 times x minus 2 minus I, x minus 2 plus I. And there you go. Questions, anybody? Yes, these are long problems. You just got to take your time. Be patient with yourself. Be cautious because it's easy to make a sign error. Questions, anybody? Oh, yeah, speaking about that, I forgot, this is the class I want to talk to about that. So what'd you guys think of that test? The grades were high. Everybody liked the take-home test, huh? Did anybody have any feedback on those tests? Because quite honestly, you guys were kind of like my guinea pig class. Since I hadn't done it for anybody else yet. Any feedback you guys have on the test other than you clearly liked it because grades were high?
We should
Will
do that.
the roll science questions on this coming test be as painful as the ones in this book?
Will the what questions?
Roll of signs questions,
The Descartes rule of signs.
yeah, be as painful
Probably,
as the
because
ones in
I'm
this book.
choosing from my math lab. But did anybody have any kind of feedback on, I mean, again, I feel like you guys must have liked it because the test grades were very high. But any feedback on the number of questions, on the timing, any of that kind of stuff?
I really liked how we had 2 attempts so that we could like see what we needed to work on and then go back and study that and just to make sure that we had a solid foundation in everything we were supposed to learn.
Well, I'm glad you went back and studied. A lot of people just did the second attempt immediately following. So I would encourage you to go back and look at stuff. Okay.
The only thing that annoys me about the online is my stupid mistakes. Like,
Yes.
if I had a paper in front of me, I know I would have looked over it all, but since it was like, I just need to go back again.
Well, aren't you writing it down? Now, I did go through every single person's test. And if you did something stupid, well, some of you emailed me and said, oh, I did something stupid. Like I put back-to-back plus signs. Or if there were really small things that I thought were syntax errors, I did go back and give people credit for that. So if you see an asterisk next to your score in the grade book, now not in the D2L grade book, it'll be in the My Math Lab grade book, then that means that I did go back and award you additional points. So if you check it out in the grade book, you may see that your grade was higher than
Awesome, thank you.
everybody else. So, hey, Lewis, you need to stick around after class and talk to me for a couple minutes, okay? I don't want to forget to mention that. Okay, all right, I just didn't want to forget because I wanted to talk to you guys kind of about the test and just what you guys thought. But good job. Clearly you guys had your resources ready to go because there were a lot of A's and B's on that.
I felt like 90 minutes when looking at it was long, but when I was doing it, it was like 10 minutes left. I'm like, where did the other 80 minutes go? Because I don't know.
All right, well, but that seemed like a fair time. So
Yes.
90 minutes, everybody got it done. Okay, all right, great. We can go back to talking about what we were. I just wanted to kind of take a side note and talk about the test, get any feedback. All right, so we got a couple more of these here. So the next example, the directions are just solve. So here, you don't have to make the chart Descartes rule of signs. You don't have to list out your entire list of possible rational zeros. If you want to, because you feel like it gives you guidance, well then great, you should use that. I would definitely not make the chart unless I got stuck and couldn't figure out what to do. We do need to list out some possible rational zeros to get us started, but I wouldn't necessarily write them all out. Now here, we're working with the constant of 12 and a leading coefficient of 1. There's not going to be very many numbers, so I probably would list them all out, but we're going to see some applications later where there are huge amounts of numbers and there's no reason to list them all. So our possible rational zeros, the factors of our constants, 1, 2, 3, 4, 6, and 12.
So why aren't we using Descartes' rule of signs this time?
Well, the directions don't make us. And I don't always feel like it's that helpful that I make a ton of decisions based off of the chart. So if you want to make it because you find it helpful, you are welcome to make it. But since the directions aren't requiring us to, I would be inclined not to. And then our leading coefficient is 1, so just 1. Now we'll simplify this list and get plus or minus 1, 2, 3, 4, 6, 12. And we can start checking zeros. I would start with positive 1 by simply adding all of our coefficients up and see if we get 0. If we add our coefficients up, we get negative 2 though instead of 0. So that tells me that positive 1 is not a 0. So I'm going to go on to a different number. What number would you like to check?
Wouldn't we usually check -1 afterwards?
There's sort of just no rhyme or reason, especially if I don't have a chart to guide me. But if you want, if that's kind of the systematic way you want to do it, is 1, -1, 2, -2, 3, -2, 3. That's fine. Just don't ignore what you get from like your upper and lower bounds if you're going to use that technique. So let's do -1. We get a remainder of -18. So that doesn't work. We'll try another number. I think I heard somebody suggest 2. And positive 2 does work. So we can start our factoring process because that's how we want to solve any kind of polynomial equation is we'll get it in factored form and then use our zero product property. We have a 0 of 2, so that gives us a factor of x minus 2. Our next factor is going to be cubic, x to the third minus 2x squared minus 3x plus 6 equal to 0. We're down to a 4-term cubic. As I mentioned before, down to 4 terms, I'm going to try factor by grouping because our other factoring techniques I think are easier than what we're learning now. So let's see, if I take an x squared out and a minus 3 out, notice that we have a common binomial factor, so that means this does factor by grouping. We get x minus 2 times x squared minus 3. Any questions on what I've done so far?
Okay, so the x minus 2 is implied as one of the 2 here.
So the first one came from the original 2 that we tested, and then the second one came from the factor by grouping.
Yes.
So this is the first time that we have had a factor with multiplicity to it in this big section here. Yes, that can happen, but I want to point something out to you on why it's so important to also use the other factoring tools we have for us. Had we not done factor by grouping, you would have checked every single number in our list of possible rational zeros and none of them would have worked. Because that x squared minus 3 is going to give us irrational zeros. If that happens where you have gone through and tested all of your possible rational zeros, you got one that worked, and then you checked all the rest of them, and none of them worked, go back and check the one that worked a second time, because it may be a zero with multiplicity like this one. But I would just recommend that as soon as you get to 4 terms, try to do factor by grouping, because that can help you out in some of these situations. All right, let's wrap it up. We're solving. I don't actually have to get down to a product of linear factors just because we're finding the solutions. And I know once we're down to a quadratic, we don't have to test zeros anymore. So I'm going to apply zero product property and set each one of my factors equal to 0 and solve. So we get x equals 2, x equals 2. And for this quadratic here, which technique would be easiest to solve?
Square root property.
Definitely. So we'll do x squared equals 3. Oh, x is going to be equal to plus or minus the square root of 3. And there's our 4 answers, although not all unique, 4 solutions. Questions?
I don't understand like how you know when you're done like checking, like for the other ones or this one too, like when we keep checking the numbers, like how do
Well,
you
once we get down to a quadratic, we shouldn't have to. So if we scroll back. Yeah, as soon as we get down to a quadratic, we're done, because we have other techniques that are easier that we've already learned to deal with quadratics. Either it's going to just factor nice, or we're going to use quadratic formula or square root property or something else to find the zeros.
Okay.
Plus, it's possible that these ones that are quadratic aren't going to be rational zeros. Like this one here, when we did quadratic formula, we got complex zeros. This next one, we got complex zeros again. This one, when we got down to a quadratic, we got irrational real zeros. So once you get it to a quadratic, now I always, when I get to 4 terms, try factor by grouping. So I guess I do a quick check at the cubic level. And then once we're at quadratics, we're done. Does that answer your question, Taylor?
Yeah.
Anybody else? Next, we'll take a look at some applications. Because again, that's why we're learning how to do all this stuff, is so that we can ultimately solve equations, and we want to solve equations that have applications to them. So they're going to give us a story here. We're going to write an equation that ends up being some high degree polynomial, and then we'll go about solving it just like we did the last equation. The height of a box containing HP LaserJet 3 printer cartridges is 4 inches more than the width, and the length is 9 inches more than the width. If the volume of the box is 630 cubic inches, then what are the dimensions of the box? Any suggestions on getting started?
List out the variables.
All right, how do you want to list them out?
Okay, so let's see. the okay, the cartridge is width plus 4, and the length is width plus 9.
Okay. All right, so the height is
So let's say
4
that
more than the
width is
width.
X.
So the width is unknown. We'll call the width just x. The height is 4 more than that. So it's x plus 4. And then the length is 9 more than the width. X plus 9. So we've labeled our box. The other piece of information they give us is that the volume of the box is 630 cubic inches. How do you find the volume of a box?
Length times width times height.
Great. Well, I know the volume, 630. I know the length, the width, and the height. So now we can put it all together into an equation. In order to solve, we need to be equal to 0. So we actually need to multiply all this out, set it equal to 0, and then check some possible rational zeros and try to get this factored. I'm going to start by multiplying the two binomials out. Distributing and combining like terms, we get x squared plus 13x plus 36. Then I'll distribute the other x, x to the third plus 13x squared plus 36x. And then we'll set it equal to 0, getting the equation 0 equals x to the third plus 13x squared plus 36x minus 630. Questions on anything we've done so far? All right, well, now it's time to try to solve this. Again, we don't need to make Descartes' rule of signs if you don't want to. That's up to you. We want to list out some possible rational zeros. I absolutely do not want to do every single possible rational zero. I mean, look at that constant, 630. There's so many factors of 630. I'm not trying to list out all of them. So what I'm going to do is I'm going to list out some and then try those. And if those don't work, then I'll list some more and then I'll try those ones and so on. Now, X represents the side of a box. When we're talking about possible rational zeros, what could you tell me about the side of this box?
There won't be any negative ones.
It won't be a negative number, right? So right away, I've already cut my list in half to just be the positive numbers. Secondly, this is a box with printer cartridges. Is it going to be 630 inches wide?
No.
No, it's going to be like a reasonable number, something, you know, I don't know, 12 and below or something. So let's just list out a handful of numbers, I don't know, 12 and below, and we'll start there. Also, the box probably is not 1 inch by 1 inch. Well, okay, I guess it wouldn't be 1 inch by 1 inch. It should be 1 inch by 5 inches by 10 inches. A box of a width of just 1 inch may not be reasonable either. So what do you guys want to choose that you think might be a reasonable number for the context of this application?
Four, maybe?
Maybe 4. All right, so let's try 4, maybe 5, maybe 6. I don't know, those kinds of numbers. All right, so let's start with 4 and divide and see what happens. All right, why don't you guys do some synthetic division there? I have to go yell at my kid. Give me 1 second. Sorry, although I muted my mic, I think I might have recorded all of that, me yelling at my kid. So sorry about that if you listen to it later. Should have paused the video too.
I didn't hear anything.
Well, I know it didn't, but I'm afraid that it because I'm recording that it would have recorded just because it's still my computer still hears me. So you may or may not be surprised. All right, here we go. Synthetically dividing. My kid has a screw gun is trying to take apart the wooden bridge of our 90-year-old next door neighbors, which he just lets the kids do anything. And I'm like, you cannot go over there and take apart his little decorative bridge. 40. Is that 68? Anybody with a calculator could help. 104, 416, I think. Negative 214. So we get a remainder of something other than 0. So that's not it. Let's try something else.
5 might work for this.
Let's try 5. There we go. We got a remainder of 0. So since we got a remainder of 0, we know we have a 0 and a factor. So I'm going to start factoring my equation. Our 0 is 5, so our factor is going to be x minus 5. And then our next factor is quadratic, x squared plus 18x plus 126. And once we get down to a quadratic, we don't have to test zeros anymore. I can either factor this using traditional methods, or we can use quadratic formula to find the zeros. Yeah, I think I'm just going to break it up into zero product property right here. So we get x equals 5. Over there, there aren't two numbers that multiply together to give us a 126 and add together to be 18. So we're going to have to use quadratic formula here. Negative 18 plus or minus the square root of 18 squared minus 4 times 1 times 126 all over 2 times 1. Somebody have a calculator handy? They can do that part underneath.
Square root of negative 180.
Negative 180. So notice that we're getting a negative number here. So that means that we're going to have an imaginary solution. X represented the side of a box. Boxes do not have imaginary sides, not if they're actually going to hold anything in it. So I wouldn't even waste my time like breaking this down. As soon as I see the imaginary number, I know that that's not a viable solution for this application problem, and we can throw it out. The only solution is going to be x equals 5. But I want to be sure I've answered the question, so I'm going to go back and reread. It says, what are the dimensions of the box? So far, we have only found the width. We need the height and the length as well. So our width is 5 inches. Our height is x plus 4, so that's going to be 9 inches. And then our length is going to be x plus 9, so that's going to be 14 inches. And there we go. Questions? Questions, anybody?
No, I think we're good.
All right, let's, oh man, I got a couple more. All right, let's try one more application problem. The front face of a tent is triangular and the height of the triangle is 2/3 the base. The length of the tent is 3 more than the base of the triangular face. If the tent holds a volume of 108 cubic feet, we want to determine the dimension. Well, I drew a tent for you, but we need to label it. It says that the height is 2/3 the base. So this right here is our height. It is 2/3 the base, which is this part down here. Our base is unknown, so we'll call this x, and then the height is 2/3 the base, so 2/3 x. And then lastly, the length of the tent is 3 more than the base of the triangular face, so x plus 3. They give us the volume of the tent. The volume is equal to 108 cubic feet. But now we have to figure out what the equation is for the volume of this tent. This tent is a triangular prism. A prism is a shape and geometry where you got some kind of geometric shape as the base. It could be a triangle, it could be a rectangle, it could be an octagon, anything. It could be a circle, and then it goes straight up with that shape. So like that's what's happening with the tent, that we have a triangle on the bottom and then it goes straight up and you end up with a triangle on top. That's what a prism is. The formula for all prisms are the same. The volume of a prism is equal to the area of the base times the height of the prism. And that's actually how even we get the volume for a box. You start with the area of the base, which is length times width, and then you multiply it by the height of it. So that's where our length times width times height. It's really the same formula for all of them. It's just this time our base is triangular. So we'll start by finding the area of our triangular base here. And we know that that's 1/2 base times height. And then we multiply it by the length of the prism. So we can say 1/2 base times height times the length. And that'll be our area formula. I'm sorry, our volume formula. We get the equation 108 equals 1/2 times x times 2/3 x times x plus 3. Just like in our previous example, we need to multiply it all out, set it equal to 0 before we start testing our possible rational zeros. I would definitely multiply these two fractions together first. 108 equals 1/3 x squared times x plus 3. Distributing. One-third x to the third plus x squared. And now we'll set it equal to 0. We want to list out some possible rational zeros to help us get started. I certainly don't want to do them all. 108 is a pretty big number. When I'm choosing some possible rational zeros to list out and test, what can you tell me about the zeros for this test?
They should only be positive.
They should only be positive, just like the previous example. And what kind of number would be reasonable? This is in feet, is our unit. So a tent that is 108 feet across, I mean, that's kind of unreasonable, right? But
Before we go on, it might be useful to include a placeholder.
I'll get there in a
0x.
second. I'll get there in a second, Anthony. So 108 would not be a reasonable number. It also wouldn't be reasonable for the tent base to only be 1 foot. So what would be like some reasonable numbers for a little tent like this?
Like 3 or 4?
Sure, let's try 3 or 4. And then if that doesn't work, then we'll add more to our list of possible rational zeros. So we'll start testing it. Anthony already noticed that we're missing an x term. And remember that synthetic division does not work if you're missing a term. You have to put a placeholder in. So he's suggesting he wants to put the placeholder in right here so that we don't possibly forget to have the placeholder in for the linear term. That's fine. You can do it here, or you can do it as we're dividing, whichever one you're more comfortable with. All right, so we said we were going to start with 3 and 4. So let's just get started. Try 3. Where do we get here? So we get -80. That didn't work. Guess we can try 4 next. I don't know, but the 3 feet wide, that's pretty tight in a little tent there. So right away, I feel like I would jump away from this one because I'm getting gross fractions to have to continue to work with. I am going to give you nice numbers that they're going to work out, and you're not going to have a whole bunch of fractions. When we get to pre-calc, well, that's a different story. But as soon as I started doing this one and got all these fractions, I've been like, nope, I'll try something else. I think this is 118 over 3. All right, not 0. So let's try something else. What do you want to try?
6.
Yeah, I would jump to 6 for sure. Because I want something that when I multiply it with that 1/3 that I get a whole number. So I'd be inclined to go with 6 as well. There we go. Remainder is 0. So I'm going to start factoring my equation here. X minus 6 times 1/3 x squared plus 3x plus 18 equals 0. We're down to a quadratic, so we don't have to test zeros anymore. I'm going to use my zero product property and break it up into 2. X minus 6 equals 0, and then this quadratic here equal to 0. And then I'll solve each one of these. X equals 6. This next equation, since that has a leading coefficient of 1/3, I don't know. I'm not going to be able to just look at that and factor it. And honestly, if I'm going to have to plug it in quadratic formula, I don't really want to have to deal with a fraction. So I'd be inclined to multiply this whole equation by 3. It's a legal math move. Whatever we do to one side, we do to the other side. But then this way, it'll just eliminate that fraction. I don't really want to work with it anytime. Our equation turns into x squared plus 9x plus 48, and I can clearly see now that that is not going to factor nicely, so we'll have to use quadratic formula. And again, if somebody with a calculator could help me out with what's underneath our radical.
Okay, the shortcut I took was b squared minus 4ac is negative. So that would mean
Right. But what'd you get? Negative what, Anthony? What's your number? Negative what?
Square root of negative 111.
All right, so we get
Or
this
that
negative
part.
number again here. So as soon as I see that negative, that tells me I'm getting an imaginary solution. And since x represents the base of a tent, an imaginary solution doesn't make sense. So this gets thrown out, and our only option is 6. The last thing I want to do is make sure I've answered the question. So I'm going to go back and reread. They want us to determine the dimensions. And so far, all I've done is found the base. So we just need to.
I'm sorry, my power is out. So
Your power, what do you mean?
my electricity.
Oh, just went out. Oh my.
Yeah, so I had to sign in on my data. I'm sorry.
Oh, okay. Oh, that's no problem. All right, so our base is going to be. Ugh, I'm running out of room. All right, I'm going to put it down here. All right, so the base is the 6 feet. The height is 2/3. So 2/3 times 6 is going to be 4 feet. And then the length plus 3 is going to be 9 feet. So there we go.
I have a question.
Yep.
Since when we write out our formula, it's x and then 2/3 times x and x plus 3.
Mhm.
Are we ever going to have more than 1 0? And we're
I mean, you
just,
could.
what would it be though?
So
Because I'm just saying there's only one variable in the like equation.
that's true. That's a great question, though. So say we ended up somehow getting, x equals 10 as well as a viable solution. If that was the case, we would just have a second set where the base equals 10, the height equals 2/3 of that, so 20/3, and then the length would be 13. So we would just have two sets of answers. You should have seen that in, what class would that have been? Maybe like 55 or even math 33 when you're,
This is the only one I've taken, so I don't know.
oh, okay, well, there you go.
It's high school.
In other classes, in prerequisite classes where they've taught you how to solve quadratic equations, maybe ones where you're like trying to build a corral to put some animals in, sometimes you would get two different answers for x, and then the dimensions of your corral you could have two different sets of answers. That's possible.
Okay.
Or maybe solving systems of equations when they're like two numbers that add together to be this and their product equals that. Sometimes we would get two possible combinations that worked.
Thank you.
Yeah, did that answer?
Yeah.
Okay, so these last two questions in this section are really questions that we already did when we were graphing polynomials. We want to find a third degree polynomial that has zeros of -1, 2, and 4, and f of 1 equals 3. So we've already done these types of problems. They just show up again in this section because theoretically, and now I will not do this, but theoretically, I could ask you to graph a polynomial function that you had to use all these possible rational zeros and all this work to get it in the factored form. So that's why we see them again in this section. So our zeros give us the factors, and then that f of 1 equals 3 we're going to use to find the leading coefficient. We're using f, and I know to use f because it says f of 1 equals 3. So f of x equals a is my unknown leading coefficient. What are my factors going to be?
X plus 1, x minus 2, and x minus 4.
I remember it's just the opposite of our zeros. And now we're going to use f of 1 equals 3 to find that leading coefficient of a. We're plugging 1 in for x and 3 in for y, aka f of x, and then we'll solve for a. We get a to be 1/2. So now we're just plugging 1/2 in for a, and that'll be our function. F of x equals 1/2 times x plus 1 times x minus 2 times x minus 4. There we go. Questions? So that one there was exactly like we saw in the section where we were graphing polynomial functions. I can tweak it just a little bit by introducing some imaginary zeros. It tells us it's going to be a third degree polynomial, but it only gives us 2 zeros. However, one of our zeros is imaginary. So remember your imaginary zeros theorem that says that if a plus bi is a 0, then a minus bi is a 0. 5i rewritten in a plus bi form is 0 plus 5i. So by our theorem, we know that 0 minus 5i must also be a 0. Our function f of x, we don't know the leading coefficient a. We have a 0 of 1. The factor that goes with that 0 is x minus 1. How about when we have a 0 of 5i? What's that factor going to be?
Is it x minus 5 plus 1 or minus I? I mean, plus I or minus I? Oh, okay.
So if you take your zeros, right? So I had to rewrite it in a plus bi form just so I could apply the theorem. But nobody really writes 0 plus 5i or 0 minus 5i. So what these mean is that x equals 5i and x equals negative 5i. To get the factor, all you do is set it equal to 0 and move that stuff over. So we're going to get x minus 5i for the first one, and then x plus 5i for the second one.
That's what I did on my paper, but then I confused myself because last time there was a sign in between the number and the I.
That's because our 0 was something like 1 plus I.
Oh, okay.
So it didn't have the 0 plus 5i, it had a actual number
Okay, that makes sense.
other than 0. So again, you got to trust the rules and not necessarily just say, oh, what do I remember it looking like last time? Be careful. All right, we're ready to find a. We're using f of negative 1 equals negative 104. So we get negative 104 equals a times negative 1 minus 1 times negative 1 minus 5i times negative 1 plus 5i. So this is a negative 2. I'm going to have to FOIL this negative 1 minus 5i, negative 1 plus 5i out. So it's going to be 1 minus 5i plus 5i minus 25i squared. Like terms in the middle fall out, we're going to replace I squared with negative 1. So we get negative 104 equals negative 2 times 1 plus 25. Negative 52a, and when we divide, we get a to be equal to 2. So our final answer, f of x equals 2 times x minus 1 times x minus 5i times x plus 5. And there we go. That is finally the end of that big mega section where we have now learned how to factor any polynomial in the whole wide world. Does anybody have any questions on it?
Yes, it's a very catch-up that we will need to do.
Is there a what that you need to do?
Catch-up videos.
Anthony, say your question again from the beginning. Is there what?
Videos to get back on track.
Oh, we're fine on timing. Don't worry. Since I lost all unit 5, we're good. We're good. So the next take-home quiz you should be able to do. I do believe I have it due for Sunday. I already put all the due dates in, so I believe Sunday night at midnight that is due, along with the homework. I know that there was an issue with my math lab last night, but we didn't have a homework due, so you guys weren't freaking out like everybody else was. So you guys aren't an issue with that. But this take-home quiz will be due on a Sunday night, and I think the homework's due the same time. And then on Wednesday, we are going to proceed into rational functions, where we're graphing all kinds of rational functions. You're always welcome to watch the videos to preview if you like, and then I will live lecture on Wednesday. Does anybody have any other questions about anything? All right, well, good job on your test. Happy everybody got a big old grade boost. I don't know how I feel about the bonus and the open book test, so we'll see about that. But okay, well, everyone have a wonderful day then. And Lewis, like I said, I need to talk to you, so please stay on.
Bye.